For this problem, we're given a ball that's dropped from a height of 10 metres. After each impact, the ball rises to 1/3 of the height from which it fell. How far does the ball travel altogether before it comes to rest? So, let's see what visually this means. If we take ourselves a ball and we have a surface, we're starting up from a height of 10 metres, we're coming down, hitting the ground. It comes up to 1/3 of that height, so 3 1/3 metres, go down, hits the ground, comes up to 1/3 of that height, go down, hits the ground, and so on. And it's going to keep on doing that, meaning that the height's going to be increasingly smaller as it goes along its journey. So let's look visually at what that means. Well, we're starting from some kind of height and we're going down by 10 metres. We're then going up by 1/3 of that height, so 10/3 metres. We're then going to come down by 1/3 by the same height, so 10/3 metres. We're then going to go up by 1/3 of that height, so 10/9 metres, down by the same amount, so 10/9 metres, up by 1/3 of that, so 10/27 metres, down by the same amount, so 10/27 metres, and so on. Now, after the initial drop, every subsequent part of the journey is going to go up and then down, so there are two parts. Well, what we can do is we can say, right, well, if we look at the first part of the journey, let's see if we can add a part to this and say, right, well, as all of these go up and down, let's add on a part of the journey where the ball travels upwards by that initial height of 10 metres before it falls. It will make this a little bit easier for ourselves. And let's constitute as this is one part of the journey. The up and down represents one part. So in total, we can say to start with, the ball has travelled by 20 metres. Then in the second part of the journey, where it goes up and down, it's travelled by 10/3 times 2, which is 20/3 metres. Then, in the next part, it's travelled by 20/9 metres. The next part, 20/27 metres, and so on. Each time there is a factor of 1/3 of the previous height. Well, looking at these terms then, can we see if there is a common value here? Well, if we take the second term divided by the first term, so u2 divided by u1, we have 20/3 divided by 20, which gets 1/3. Check it, take another two pair of terms. Let's take u4/u1, 20/27 divided by 20/9, which is 9/27, which again is 1/3. So we still have this factor between the terms here of 1/3. Well, if that factor is consistent, that means we have a common ratio there. If we've got a common ratio, it's the same between each of our terms, then it's just a geometric sequence that we've generated. Now, specifically, we want to know how far the ball has travelled all together. So, because it's all together, we're really going to add up all of these terms. So actually, we're changing this into a geometric series because we want to add up the terms. Well, if we're adding up the terms, it means we're looking for a summation. Because it's a geometric, we have a formula. We have a times 1 minus r to the n over 1 minus r. And that would be our normal summation formula. However, this would imply that we've got a fixed number of terms. But the problem with this is because there is a multiplication each time of 1/3, yes, the distance is going to get increasingly smaller and smaller and smaller, but actually it means that we're going to go to an infinite number of terms. This is going to happen in an infinite number of times. So it's not that we want the sum of the first n terms, we are actually looking at the sum to infinity formula, which is a over 1 minus r. Okay, so that's the formula for this that we really need to use. In another problem, it might tell you that it drops, that it falls and rises a fixed number of times. But for this one, it doesn't. There's just a multiplier of 1 over 3. So actually, this is going to happen an infinite number of times. So we've got our R value. For the summation to infinity, we need an A value. Well, that's easy enough. That's just our first term, which is 20. So if we substitute in, we have 20 over 1 minus a third, which is 20 divided by 2/3. 20 divided by 2/3, which is the same as 30, and this is a distance, so 30 meters. And you might think that's where we need to stop, but actually you need to think about what we did to the model near the very start of the problem. To make our terms match, so we've got a part going up and down, we've introduced this initial 10 meters that wasn't actually in our problem. So we need to remove that now. So total distance travelled by the ball is, we take our 30 meters, we subtract that original 10 meters to get us to 20 meters. Okay, don't forget, if you've added a part to make this into a geometric series, that you need to take that into account in your final solution.